In the pre-dawn darkness of a Michigan winter morning in 1944, the sound of machinery never ceased. Inside the longest building ever constructed by human hands, a mile-long assembly line moved with the precision of a Swiss watch and the power of an American locomotive. Every 63 minutes, like clockwork, the massive doors at the end of Ford Motor Company's Willow Run plant would roll open, and another four-engine B-24 Liberator bomber would emerge into the frigid air, fully fueled, fully armed, and ready for war. Where Ford Motor Company built one B-24 Liberator airplane every 63 minutes, a production rate that seemed to defy the laws of physics, economics, and common sense. 67 feet long, the B-24 had 450,000 parts and 360,000 rivets in 550 sizes, and it weighed 18 tons. To witness this mechanical symphony was to observe the very essence of American industrial might, what President Roosevelt had christened the arsenal of democracy. But Ford's achievement was more than just an impressive feat of manufacturing. It represented a fundamental transformation in the way war could be waged, a revolution in production that would not only determine the outcome of World War II, but reshape the entire global balance of power. And perhaps no one understood the implications of this transformation better than the German spies who desperately sought to uncover the secrets of American industrial capacity. The story begins in 1940, when America stood at the crossroads between peace and war. President Roosevelt stunned millions of listeners when he announced, during a May 26, 1940, fireside chat that government must harness the efficient machinery of America's manufacturers to produce 50,000 combat aircraft over the next 12 months to confront the approaching storm of global war. FDR's goal exceeded the total of all planes built in the U.S. since the Wright brothers' 1903 flight at Kitty Hawk, NC, and he challenged the aviation industry to match that number in succeeding years. To comprehend the magnitude of this challenge, one must understand the state of American aircraft production in 1940. The entire American aviation industry was still essentially a cottage enterprise, with skilled craftsmen hand-building each aircraft as though it were a piece of furniture. Handcrafted versions were pressed into service in England. But the San Diego company lacked resources and methods for high-volume production of the largest, most complex airplane ever designed. The idea that America could mass-produce heavy bombers the way Henry Ford had mass-produced automobiles seemed as fantastical as the flying machines themselves had once appeared to skeptics. Skeptics scoffed at the idea that Ford Motor Co. could mass-produce heavy aircraft. "You can't expect a blacksmith to make a watch overnight," sniffed Dutch Kindleberger, president of North American Aviation. The comparison was apt. Aircraft were not automobiles. They were infinitely more complex, requiring precision engineering, exotic materials, and constantly changing specifications dictated by the evolving demands of combat. How could the mass production techniques that had revolutionized the automotive industry possibly be applied to the most sophisticated machines ever conceived by human ingenuity? The answer lay in the vision of one man, Charles Emile Sorensen, Ford Motor Company's vice president of production. Charles Sorensen, vice president of production for Ford, traveled to San Diego to observe Consolidated Aircraft's operations. Here's his description of the visit and how he conceived the Willow Run bomber plant that eventually manufactured 8,800 of these aircraft. What Sorensen witnessed at Consolidated Aircraft's San Diego facility shocked him, not because of its sophistication, but because of its inefficiency. Inside the Consolidated plant, I watched men putting together wing sections and portions of the fuselage. I knew I had the solution, and I was elated by the certainty that the Germans had neither the facilities nor the conception for greater bomber mass production. Towards 4 o'clock, I was satisfied that my piles of paper were arranged in proper order and represented the most logical progress of units to the main assembly line. And I knew I could prove a construction rate of one big bomber an hour. That evening, in his hotel room at the Coronado, Sorensen experienced what can only be described as an industrial epiphany. As soon as I returned to my room at the Coronado Hotel, I began figuring how to adapt Ford assembly methods to airplane construction and turn out one four-engine bomber an hour. Throughout the day, I had made copious notes. I listed all major units of the plane and the subunits and fractional units required for their assembly. And I had gathered figures on Consolidated's labor force and job performance. From these, I computed each unit operation, its timing, and required floor space as I saw them, and paper began to fly. Figures for each unit I kept together in a separate pile, and soon there were little stacks of paper all over the floor of my room. Standing over the papers, I roughed out on Coronado Hotel notepaper a pencil sketch of the floor plan of a bomber plant. It would be 1 mile long and 1/4 mile wide, the biggest single industrial building ever. I still have that sketch, initialed by Edsel Ford, his 2 sons and others, and I still get a kick out of it. The result of one night's hard work, it is the true outline of Willow Run, which took 2 years to build and came through on schedule with one 4-engine Liberator an hour, 18 bombers a day. And by the end of the war, a total of 8,800 big bombers. The conceptual breakthrough that Sorensen achieved that night was deceptively simple yet revolutionary in its implications. To compare a Ford V8 with a 4-engine Liberator bomber was like matching a garage with a skyscraper. But despite their great differences, I knew the same fundamentals applied to high-volume production of both, the same as they would to an electric egg beater or to a wristwatch. First, break the plane's design into essential units and make a separate production layout for each unit. Next, build as many units as are required, then deliver each unit in its proper sequence to the assembly line to make one whole unit. Finished plane. To house all this and provide for efficient operation, there should be a new plant specially designed to accommodate the progressive layout. I saw no impossibility in such an idea, even though mass production of anything approaching the size and complexity of a B-24 never had been attempted before. The implications of Sorensen's vision extended far beyond the mere production of aircraft. What he was proposing was nothing less than the industrialization of warfare itself, the transformation of military conflict from a contest of individual skill and bravery to a battle of productive capacity and organizational efficiency. In this new form of warfare, victory would belong not to the nation with the bravest soldiers or the most brilliant generals, but to the nation that could most efficiently convert raw materials into weapons of war. This philosophical shift did not escape the attention of German intelligence services, who had been monitoring American industrial capacity with growing alarm since the beginning of the European War. During the early months of the war, the major contributions of the United States to oppose the Nazi war machine involved industrial production, equipment, and supplies furnished to those forces actively defending themselves against the German armed forces. That industrial effort was strong enough to generate frustration, perhaps indignation, among the Nazi high command, and the order was given, allegedly by Hitler himself, to mount a serious effort to reduce American production. German intelligence settled on sabotage as the most effective means of diminishing our input. The German intelligence services, collectively known as the Abwehr, had been attempting to gather information about American production capabilities since the late 1930s. Throughout the war, the Germans sought military, political, and economic information of any and all types. and the broad assignments given agents may well be one reason for the failure to obtain specific data of high quality. At the same time, certain subjects received special emphasis. Among these were data on aircraft production and types and information on anti-submarine devices. The German effort to penetrate American industrial secrets had achieved some notable successes before the war began. Nevertheless, Pfeiffer was particularly interested in new technical developments in the fields of ship design, armament, and special equipment. It was through one of his volunteer agents on the liner Bremen that Pfeiffer made contact with the notorious Dr. Griebel, who over a period of time supplied him with information on United States aircraft. The most successful German intelligence operation against American aircraft production had been conducted by the Duquesne spy ring. Before America ever fired a shot in World War II, we had rolled up a massive ring of Nazi spies operating on U.S. soil, 33 in all, ranging from Paul Bante to Bertram Wolfgang Zenzinger. By December 13, 1941, just 6 days after Pearl Harbor, every member of the group had either pled guilty or been convicted at trial, including its ringleader Fritz Duquesne. The intelligence gathered by these operatives had provided Germany with valuable insights into American aviation technology and production methods. Heine sent letters from Detroit, Michigan, to Lily Stein, one of the German spies Siebold was instructed to contact. The letters contained detailed technical data regarding the military, aircraft construction, and various industries. He also wrote to aircraft companies to obtain information about their production, number of employees, and the time required to construct military planes. After obtaining technical books relating to magnesium and aluminum alloys, Heine sent the materials to Heinrich Ehlers. However, the intelligence picture these spies provided to Berlin was fundamentally incomplete. They could gather information about existing production facilities and techniques, but they could not anticipate the revolutionary transformation that was about to take place at Willow Run. But, in general, Nazi intelligence efforts in the United States were comically inept, more Colonel Klink than supervillain. Establishing a robust network of spies within the United States was never a priority for the German regime. No one wanted to repeat the mistakes of World War I, when efforts to spy on the Americans had only antagonized them and brought them into the war. Combined with the usual tensions between competing branches of the Nazi state, support for spies remained ambivalent for much of the decade. As a result, Nazi operations were small-scale sideshows for most of the 1930s. By the end of the decade, when the war ramped up and caution could be abandoned, it was too late to cultivate agents with sufficiently deep cover. Nazi intelligence therefore relied on a haphazard crew of amateur agents, none of whom were really up to the task. The construction of Willow Run began in earnest in 1941, representing one of the most ambitious industrial projects in human history. Architect Albert Kahn designed the main structure of the Willow Run bomber plant, which had 3,500,000 square feet, 330,000 m² of factory space, and an aircraft assembly line over a mile, 1,600 minutes, long. It was thought to be the largest factory under one roof anywhere in the world. The scale of the project was breathtaking. It was constructed in 1941 by the Ford Motor Company for the mass production of the B-24 Liberator military aircraft. The U.S. government contributed $200 million to the project. Originally 975 acres of farmland owned by Henry Ford, the site was developed by the Ford Motor Company into what was described as the largest war factory in the world. But the construction of the physical plant was only the beginning of the challenge. The real difficulty lay in adapting automobile production methods to aircraft manufacturing, a process that would prove far more difficult than Sorensen had initially anticipated. Ford had no say in the matter, Production chaos ensued. For the next 6 months, Sorensen shuttled 70-man teams of engineers and draftsmen back and forth on 2,300-mile trips from Ford headquarters to the Consolidated Works in San Diego to immerse themselves in B-24 design, engineering, parts, and components. To their dismay, they discovered that engineering drawings for the big bomber were useless, incomplete and filled with discrepancies and unfamiliar signs and symbols. An unknown number dwelt in the memories of plant foremen. Ford was building the B-24s at Willow Run, but Consolidated was still in charge, and it had no blueprints for Ford to work from, just sketches, drawings, and templates. The materials were nothing Ford could use in his efficient assembly line, so he had 200 engineers work in shifts around the clock, 7 days a week. They produced 5 miles of drawings a day based on Consolidated's materials. 10,000 of the 30,000 drawings the engineers made were obsolete by the time they got them back to Detroit from San Diego. All the tooling they designed now doesn't work because Consolidated changed the airplane every day, Houghton said. The early months of production were a disaster by Ford standards. Only 56 airplanes were built in all of 1942. But as 1943 arrived, problems got solved and Willow Run turned a corner. Numbers climbed steadily throughout the year. Ford built 37 planes in January, 70 in February, 96 in March, and 146 in April. Critics began calling the facility Will It Run rather than Willow Run. As the problems continued into 1943, critics took to calling the plant Will It Run. The skepticism reached the highest levels of government when Willow Run's problems came under a microscope in April 1942 and again in February 1943, when Senator Harry S. Truman visited the plant. Truman headed a presidential committee charged with eliminating wartime production waste, and Willow Run's struggles worried him. Ford President Edsel Ford and his team explained the difficulties with design changes. Truman was unimpressed. He didn't want excuses. He wanted finished bombers. However, Ford's engineers were systematically solving the fundamental problems of aircraft mass production. Sorensen and his team methodically broke the complex bomber plane into 11 major assemblies, and then further divided these into 69 sub-assemblies. The team developed the B-24's build sequence from these divisions. This approach represented the application of scientific management principles to aircraft production on a scale never before attempted. The breakthrough that enabled Willow Run to achieve its legendary production rates came in 1943, when Ford engineers perfected the center wing assembly process. The center wing assembly was key to meeting that bomber-an-hour quota, Houghton said. All the prefabricated structures had all been pre-manufactured. They didn't have to be fit. They would snap into place. Workers put the parts in the wing. Riveters knocked the wing parts together. Then the center wing assembly was sent to a multiple-function machine that completed 42 precision machining operations to 0.02" in 17 minutes. This innovation was revolutionary, not just in its technical achievement, but in its philosophical implications. Ford had essentially transformed the B-24 from a handcrafted artifact into a manufactured product. Each component was designed to precise tolerances that allowed parts from different sub-assemblies to fit together without modification or adjustment, a level of precision that was virtually unknown in aircraft manufacturing at the time. The human dimension of Willow Run's achievement was equally remarkable. By mid-1944, the Willow Run assembly plant was producing 1 B-24 per hour, accounting for half of all B-24s assembled that year. Some 12,000 women worked at the Willow Run bomber plant, each paid the same 85 cents an hour as their male counterparts. Architect Albert Kahn boasted that the Willow Run plant would be the most enormous room in the history of man. Out of sheer necessity, Willow Run's 42,500-member workforce became a model of diversity for future generations. The social transformation represented by Willow Run was as significant as its industrial achievement. Many women were hired to replace men drafted into the war, leading to the creation of the Rosie the Riveter character. The factory became a symbol not just of American productive capacity, but of American social flexibility and adaptability. The infrastructure required to support Willow Run's operation was itself a marvel of engineering and logistics. In 1942, the federal government built the nation's second freeway, now I-94, to move workers and materials to the Willow Run plant. In 1943, it spent $20 million to construct an entire community adjacent to the plant. In a matter of days, the government erected dormitories for single workers and enough small houses to accommodate 3,000 people. Willow Village provided housing for more than 15,000 people. The village grew to include 30 dormitories, 6 community buildings, rows and rows of small houses, commercial buildings, police and fire stations, and schools. As production efficiency improved throughout 1943 and 1944, Willow Run began achieving the production rates that Sorensen had originally envisioned. On November 3, 1943, employees celebrated as Willow Run turned out its 1,000th finished B-24 bomber. Employees at Willow Run celebrated the completion of their 6,000th airplane in September 1944. Ford now planned to build 650 planes each month, one every 45 minutes. But just when that milestone seemed possible, the government drastically cut its order for B-24s. The peak achievement of Willow Run came in 1944, when by 1944, Ford was rolling a Liberator off the Willow Run production line every 63 minutes, 24 hours a day, 7 days a week. At its peak monthly production, April 1944, Willow Run produced 428 B-24s with highest production, listed as 100 completed bombers flying away from Willow Run between April 24 and April 26, 1944. By 1945, Ford produced 70% of the B-24s in 2 9-hour shifts. The statistical achievement of Willow Run is almost incomprehensible when viewed in historical context. By the end of the war, Ford had pushed 8,965 B-24 heavy bombers out the Willow Run doors for the Army Air Force. The plant went from building just 1 plane a month in October 1942 to nearly 500 a month by June 1944, with the capability of creating 650 B-24s a month by fall. By the time the last B-24 rolled off the Willow Run assembly line on June 28, 1945, the plant had produced more than 92 million pounds of airplanes. In 1944 alone, Willow Run produced nearly as many aircraft as the entire nation of Japan, according to the Ann Arbor Observer. This last statistic, that a single American factory was outproducing the entire Japanese aircraft industry, provides crucial insight into why German intelligence was so desperate to understand American production methods. The implications for the global balance of power were staggering. If the United States could mass-produce complex military equipment on this scale, no amount of tactical brilliance or individual heroism could overcome such an enormous material disadvantage. German attempts to gather intelligence on American production continued even as their spy networks were being systematically dismantled by the FBI. The failure of Operation Pastorius caused Hitler to rebuke Admiral Canaris, and no sabotage attempt was ever made again in the United States. During the remaining years of the war, the Germans only once more dispatched agents to the United States by submarine. In November 1944, as part of Operation Elster, the German submarine U-1230 left 2 SS Reichssicherheitshauptamt, Reich Security Main Office, spies on the coast of Maine to gather intelligence concerning American manufacturing and technical progress. After a month of high living in New York City, but no espionage gathering, one of the men turned himself in to the FBI, which captured both agents soon afterward. Both were convicted and sentenced to death, with their executions stayed throughout the duration of the war, after which their punishment was commuted by President Truman into life sentences in prison. The mission of Operation Elster specifically targeted American manufacturing capabilities. Originally intended to gather information gauging the effectiveness of Nazi propaganda in the United States, the objective of Operation Magpie was later widened to include the gathering of technical engineering information, generally from public sources. Of particular interest was intelligence on shipyards, airplane factories, and rocket testing facilities. However, by 1944, it was too late for intelligence gathering to make any strategic difference. The German war economy, despite its reputation for efficiency, was simply incapable of matching American productive capacity. Nicholas controlled 2 agents in the U.S. and had other contacts providing classified information on U.S. bombers and fighter planes, and on the production levels of U.S. oil, aluminum, and steel, according to the WW2 book, Tango Wars. Yet even perfect intelligence could not have bridged the fundamental gap in industrial capability that separated Germany from the United States. The scope of American industrial mobilization extended far beyond Willow Run. Ford Motor Company built everything from Jeeps to generators during World War II, but nothing else was on the scale of Willow Run. Every American automaker turned its workforce and facilities to military production during World War II. But no project captured the public's imagination like Willow Run, where Ford Motor Company built one B-24 Liberator airplane every 63 minutes. The plant was the embodiment of America's arsenal of democracy, the enormous manufacturing capacity so vital to the Allies' victory. Every American automaker turned its workforce and facilities to military production during World War II. But no project captured the public's imagination like Willow Run, where Ford Motor Company built one B-24 Liberator airplane every 63 minutes. The plant was the embodiment of America's arsenal of democracy, the enormous manufacturing capacity so vital to the Allies' victory. The B-24 Liberator itself was a remarkable achievement of engineering and design. The consolidated B-24 Liberator is an American heavy bomber designed by Consolidated Aircraft of San Diego, California. At its inception, the B-24 was a modern design featuring a highly efficient shoulder-mounted high-aspect ratio Davis wing. The wing gave the Liberator a high cruise speed, long range, and the ability to carry a heavy bomb load. In comparison with its contemporaries, the B-24 was relatively difficult to fly and had poor low-speed performance. It also had a lower ceiling and was less robust than the Boeing B-17 Flying Fortress. While aircrews tended to prefer the B-17, General Staff favored the B-24 and procured it in huge numbers for a wide variety of roles. At approximately 18,500 units, including 8,685 manufactured by Ford Motor Company, it holds records as the world's most produced bomber, heavy bomber, multi-engine aircraft, and American military aircraft in history. Approximately 18,500 B-24s were produced across a number of versions, including over 4,600 manufactured by Ford. The complexity of the B-24 made Ford's achievement even more remarkable. As the war progressed, the complexity of servicing the Liberator continued to increase. The B-24 variants made by each company differed slightly, so repair depots had to stock many different parts to support various models. Such things as boot-type de-icers, different bombardiers, scan windows, flush-type pivots, different paint schematic for the anti-glare panel, inward-outward nose gear door panels, and wingtip lights, all of which could give mechanics working in the various theaters of operation nightmares. Several different sets of prints were required to understand which parts were interchangeable or custom, depending upon the originating plant. The manufacturing challenges posed by the B-24 extended far beyond simple assembly line production. The Liberator production pool did not operate completely trouble-free. Parts made by different factories were not always interchangeable, and implementing the countless required changes consistently was a headache. Eventually, separate modification centers were set up to upgrade planes that had just left the factory, but were already obsolescent. Ford's solution to these challenges represented a fundamental advance in manufacturing science. By developing unprecedented precision in parts manufacturing and assembly techniques, they were able to achieve levels of interchangeability and quality control that had never before been attempted in aircraft production. This achievement required not just mechanical innovation, but also organizational innovation on a massive scale. The training requirements for Willow Run's workforce represented another dimension of Ford's achievement. Training. The Aircraft Apprentice School had up to 8,000 students per week complete training and report for work. The transformation of automobile workers into aircraft assemblers required extensive retraining and skill development programs that were themselves innovations in industrial education. The psychological impact of Willow Run extended far beyond its immediate military significance. For the first time in human history, a single industrial facility was producing finished military aircraft at a rate that exceeded the production of entire nations. This achievement represented a new form of warfare, industrial warfare, in which victory would be determined not by traditional military virtues, but by organizational efficiency and productive capacity. The German response to intelligence reports about American production was a mixture of disbelief and alarm. German military leaders, trained in the traditional concepts of warfare, found it difficult to accept that industrial production could have such a decisive impact on military outcomes. The idea that a single factory could determine the outcome of a global war challenged fundamental assumptions about the nature of conflict itself. The failure of German intelligence to provide adequate warning about American productive capacity was not merely a tactical failure. It was a strategic catastrophe. By the time German leaders fully understood the implications of facilities like Willow Run, it was too late to develop effective countermeasures. The window of opportunity for Germany to win the war had already closed, sealed shut by the inexorable mathematics of American industrial production. The workers at Willow Run understood that they were participants in a new form of warfare. Meanwhile, able-bodied men were drafted or volunteered for military service, and Ford started hiring women. By May 1942, 15% of the Willow Run workforce was women, and they were earning the same wages as men did for the same jobs. 13 months later, employment peaked at 42,000, and by summer 1944, the factory was humming along. Production had peaked at a bomber an hour, just as Henry Ford had promised, and employment was reduced to $17,000, thanks to the efficiencies the auto industry had applied to making the B-24. The efficiency gains achieved at Willow Run were so dramatic that they actually reduced employment even as production increased. This paradox, fewer workers producing more aircraft, represented the ultimate validation of Sorensen's original vision. Mass production techniques had not only made aircraft manufacturing faster and cheaper, they had made it fundamentally more efficient. The strategic implications of Willow Run extended far beyond the production of bombers. The facility demonstrated that American industry possessed the capability to mass-produce any type of military equipment with unprecedented speed and efficiency. This capability fundamentally altered the strategic calculus of warfare, making prolonged conflicts with the United States virtually unwinnable for any opponent. German intelligence reports about American production capabilities, when they reached Berlin, painted a picture of an industrial machine unlike anything the world had ever seen. The concept of producing a complex four-engine bomber every 63 minutes was so far outside previous experience that German military planners struggled to comprehend its implications. How could traditional military strategy and tactics compete against such overwhelming material superiority? The answer, as events would prove, was that they could not. The B-24s rolling off the Willow Run assembly line would play crucial roles in every theater of World War II. The liberators made a significant contribution to Allied victory in the Battle of the Atlantic against German U-boats. Liberators assigned to the RAF's Coastal Command in 1941, offensively to patrol against submarines in the eastern Atlantic Ocean, produced immediate results. The introduction of Very Long Range, VLR. Liberators vastly increased the reach of the UK's Maritime Reconnaissance Force, closing the mid-Atlantic gap where a lack of air cover had allowed U-boats to operate without risk of aerial attack. In the Pacific theater, B-24s would prove equally significant in the strategic bombing campaign against Japan and in supporting amphibious operations across the vast distances of the Pacific. In Europe, they would join the massive bombing campaigns that systematically destroyed German industrial capacity and transportation networks. Each of these aircraft represented not just a weapon of war, but a product of American industrial civilization at its peak. The cultural impact of Willow Run was as significant as its military impact. The facility became a symbol of American capability and determination, proof that the United States could not only match but exceed the industrial achievements of any nation on Earth. For Americans, Willow Run represented validation of their economic system and their way of life. For America's enemies, it represented a fundamental challenge to their assumptions about American capability and resolve. The press coverage of Willow Run reflected the public's fascination with this industrial marvel. The media was watching all of this closely, and the Detroit Free Press ran a story boasting that Willow Run would be able to build a bomber a minute by summer. While this particular prediction proved overly optimistic, the actual achievement of one bomber every 63 minutes was scarcely less remarkable. The international implications of Willow Run extended beyond the immediate context of World War II. The facility demonstrated that American industry possessed capabilities that could reshape the global balance of power. For the first time in history, a single industrial facility could produce military equipment at a rate that exceeded the capacity of entire nations. This achievement suggested that future conflicts would be determined not by traditional military factors, but by industrial capacity and organizational efficiency. The German intelligence failure regarding American production capabilities was symptomatic of a broader failure to understand the nature of modern warfare. German military doctrine, rooted in concepts of rapid conquest and tactical supremacy, was ill-equipped to deal with the realities of industrial warfare. The idea that a war could be won or lost in factories rather than on battlefields was foreign to German military thinking. The workers who built B-24s at Willow Run were, in a very real sense, soldiers in the industrial war. Their contribution to victory was as essential as that of any combat unit. The aircraft they produced would carry the war to Germany itself, demonstrating the global reach of American industrial power. Each B-24 that emerged from Willow Run carried with it the accumulated expertise of American industry. The dedication of American workers and the productive capacity of the American economy. The technological innovations developed at Willow Run would have lasting impact far beyond the war years. The precision manufacturing techniques, quality control methods, and organizational systems pioneered at the facility would become standard practices in post-war industry. The facility served as a laboratory for industrial innovation, developing methods and techniques that would transform manufacturing across a wide range of industries. The management challenges overcome at Willow Run were as significant as the technical challenges. Coordinating the activities of 42,500 workers in a facility covering 3.5 million square feet of floor space required organizational innovations that had never before been attempted. The systems developed for production planning, inventory control, and quality assurance would become models for industrial organization throughout the post-war period. The global implications of Willow Run became apparent as the war progressed. The Army literally said, "Slow down. We have no place to park them. The losses in combat haven't been what we expected," Houghton said. In 1944 alone, Willow Run produced nearly as many aircraft as the entire nation of Japan, according to the Ann Arbor Observer. Given the limited capacity of the aircraft industry and the enormous pressure for airplanes, it was fair to conclude the Army Air Force was justified in underwriting this Ford experiment, Houghton said. The fact that combat losses were lower than expected was itself a testament to the quality of the aircraft produced at Willow Run. Ford's application of automobile production techniques had not compromised the quality of the final product. If anything, the standardization and precision of mass production had improved quality and reliability compared to hand-built aircraft. The aftermath of Willow Run's achievement would reshape global perceptions of American capability. No longer could the United States be dismissed as an industrial newcomer, lacking the sophistication and expertise of European manufacturers. Willow Run demonstrated conclusively that American industry could not only match but exceed the achievements of any nation on Earth. The psychological impact of Willow Run on both allies and enemies cannot be overstated. For America's allies, the facility represented hope, proof that the United States possessed the industrial capacity necessary to wage and win a global war. For America's enemies, it represented despair, evidence that their chances of victory were diminishing with every B-24 that rolled off the assembly line. The legacy of Willow Run extends far beyond its immediate contribution to the war effort. The facility demonstrated principles of industrial organization and manufacturing efficiency that would shape the post-war global economy. The concept of mass production, refined and perfected at Willow Run, would become the foundation of American economic dominance in the post-war era. The social implications of Willow Run were equally significant. The facility had demonstrated that American society possessed the flexibility and adaptability necessary to mobilize resources on an unprecedented scale. The successful integration of women into the workforce, the training of unskilled workers for complex technical tasks, and the coordination of diverse groups toward a common goal represented achievements in social organization that were as remarkable as the technical achievements. The German spies who sought to uncover the secrets of American production had witnessed something unprecedented in human history: the birth of modern industrial warfare. They had observed the transformation of the American economy from a peacetime to a wartime footing, the mobilization of resources on a scale never before attempted, and the application of scientific management principles to military production. But the most profound revelation was not technological or organizational. It was philosophical. Willow Run represented a new conception of warfare itself. one in which victory would be determined not by the clash of armies, but by the efficiency of factories, not by the courage of soldiers, but by the productivity of workers, not by the brilliance of generals, but by the effectiveness of production managers. The B-24 Liberators that emerged from Willow Run every 63 minutes carried with them more than bombs and bullets. They carried the accumulated industrial might of the American economy, the organizational genius of American management, and the dedicated labor of American workers. Each aircraft was a testament to the proposition that in modern warfare, the factory was as important as the battlefield, the assembly line as crucial as the front line. The German intelligence services that sought to penetrate the secrets of American production had encountered something beyond their understanding. Not just a new type of factory, but a new form of civilization. They had witnessed the emergence of the United States as not merely a great power, but as an industrial superpower capable of producing military equipment on a scale that dwarfed the capabilities of any potential opponent. In the end, the German spies who were shocked by Ford's ability to build a 1.5 million part bomber every 63 minutes had witnessed nothing less than the future of warfare itself. They had seen the birth of the military-industrial complex that would dominate global affairs for the remainder of the 20th century. They had observed the transformation of the United States from an isolated democracy into the arsenal of democracy that would reshape the global order. The story of Willow Run is ultimately the story of American industrial civilization at its peak. A civilization capable of mobilizing unprecedented resources, organizing vast enterprises, and achieving seemingly impossible goals. The B-24 Liberators that rolled off the assembly line every 63 minutes were more than weapons of war. They were symbols of American determination, ingenuity, and productive capacity. As the war ended and the last B-24 emerged from Willow Run in June 1945, on June 28, 1945, production ceased, after 8,685 planes had been manufactured. The facility had achieved something unprecedented in human history: the mass production of complex military equipment at a scale and rate that had seemed impossible just 5 years earlier. The German spies who had sought to uncover the secrets of American production had witnessed the birth of a new age, the age of industrial warfare, in which victory would belong to the nation with the most efficient factories, not necessarily the bravest soldiers. The workers at Willow Run had won a victory as decisive as any achieved on any battlefield. They had demonstrated that American industry possessed capabilities that could not be matched by any combination of opponents. They had proven that the United States possessed not just military strength, but industrial strength of unprecedented scale and sophistication. In the final analysis, Willow Run represented more than just an achievement in aircraft production. It represented the triumph of American industrial civilization. The facility had shown the world that the United States possessed the organizational capability, technical expertise, and productive capacity necessary to wage and win modern warfare. The B-24s that emerged every 63 minutes carried with them the message that America had become not just a great power, but the supreme industrial power of the modern age. The German spies who sought to understand the secret of American production had discovered a truth that would reshape the global order, that in the modern world, industrial capacity was military capacity, productive efficiency was strategic superiority, and organizational excellence was the foundation of national power. At Willow Run, they had witnessed the birth of the American century,